All right, welcome. Today we're diving into a crime that costs factories millions every single day. We're talking about a massive, invisible energy heist. And you know what? The culprit is hiding in plain sight.
Just think about that for a second. What if the one machine you absolutely rely on the most is also the one that's just draining your profits? For a lot of manufacturers, this isn't some hypothetical question. Nope, it's their daily reality.
You've got electricity, water, and gas, and then there's compressed air. It's really the lifeblood of modern industry. It powers tools, it moves materials, it basically makes modern production possible. It's so important that people call it the fourth utility. But this utility has a bit of a dark secret. 40%. Just let that sink in. That's how much energy can be completely lost in these compressed air systems. It's a staggering number, and it points to a huge inefficiency that, honestly, often gets completely overlooked.
So today, we're going to go undercover. We're going to follow a real-world case study, an energy audit that reads just like a detective story. We'll follow the clues, we'll analyze the evidence, and we are going to unmask the culprit behind this huge energy waste.
Okay, so our investigation starts at a manufacturing plant. They've got a serious but totally hidden energy drain. They kind of knew something was off, but they had no idea what it was. So what's the first step for our energy detectives? Find the right clue.
You know, in any good investigation, you have to know what you're looking for, right? Well, in the world of compressed air, the single most important piece of evidence is a metric called SPC. That stands for specific power consumption. Think of it as the fingerprint of inefficiency.
So what exactly is SPC? The easiest way to think about it is like a car's fuel efficiency, kilometers per liter. SPC measures how much electricity a compressor uses to produce a certain amount of air. And just like with your car, a lower number is way, way better. Means you're getting more for your money.
And this really gets to the heart of our case. A low SPC? That's a green check mark. It means your system is running lean and mean. But a high SPC? That's the big red flag. It's a siren telling you that energy and a whole lot of money is being wasted. That high number is exactly what our detectives are hunting for. All right, so with their key metric in hand, the investigators started gathering evidence. They'd hooked up some pretty advanced sensors to measure both power consumption and airflow in real time. And the best part? They did all of this without disrupting the factory's daily operations at all.
Now let's meet our main suspects, two identical, very powerful 75 kilowatt air compressors. On paper, these things look more than capable, right? They're beasts. But the real question is, are they the right tools for this specific job? The data was about to tell all.
And here it is, our first major clue. Just look at that gap. The system was built to supply over 500 cubic feet of air per minute, but the factory's actual real-world demand was only about 57. That is like using a giant fire hose to water one tiny potted plant. So here's the crucial takeaway. The compressor was barely breaking a sweat. Now, you might think, hey, that saves energy. But it's actually the exact opposite. See, these big compressors are designed to work hard. When they're barely running, they waste a ton of power just staying on. It's like a car burning gas while it's just sitting there idling in traffic. All waste.
Okay, so the evidence was all pointing to a huge mismatch, but our investigators needed that one last piece of definitive proof, the smoking gun, the piece of data that would show them exactly how and why so much energy was being wasted.
And there it is, the smoking gun. This chart shows that for nearly 87% of the time it was running, the compressor was operating in its least efficient zone, somewhere between 20 and 40% load. It was constantly idling, never even getting close to its performance sweet spot. This is the classic signature of an oversized machine. And the numbers just confirmed it. The actual specific power consumption was 0.334. An ideal, properly sized system for this factory, it should have been around 0.16. The inefficiency was undeniable. This system was using more than double the energy it should have been. Case closed on what the problem was. Now, identifying the problem is one thing, but a good detective also brings you the solution. And in this case, the fix wasn't about some super complex, expensive new technology. No, it was about simple, smart engineering. The logic here was just beautifully simple. The problem was a 75 kilowatt compressor doing a job that needed way less power. So, the solution? Swap it out for a 25 kilowatt compressor that perfectly matched what the factory actually needed. See, it's not about having the biggest machine, it's about having the right machine.
And the result of this one simple change? How about an annual savings of over 3.6 lakh rupees? That's real money, recovered directly from what used to be wasted energy that can now go straight back into the business. The solution was simple, but the impact was absolutely huge. Let's just look at the final numbers to see just how effective this one single data-driven decision really was. I mean, the before and after data here tells the entire story. By right-sizing the machine, they slashed their SPC by nearly 40% and cut power consumption way down. The new compressor, which cost about 4.5 lakh, paid for itself in just 15 months through pure energy savings. That is an absolutely incredible return on investment.
So, how can you apply all this to your own operations? Well, this case gives us a really clear roadmap. It all starts with measuring your actual demand, what you really need. From there, you've got to track your SPC. It's one of the best indicators of your system's health. And finally, you can hunt for sneaky leaks and, most importantly, follow that golden rule we saw here. Match your supply to your demand.
And really, it all comes down to this simple idea. This case wasn't solved with a hunch or a guess, it was solved with data. By measuring the system, the engineers could finally understand it, which allowed them to improve it and ultimately make the whole operation more profitable. It's a powerful reminder that sometimes the biggest opportunities are hiding in the places we look the least. So the question is, what hidden costs might be lurking in your own systems?